hidden power rages through our planet, now made visible for the first time. Satellites scanning the Earth reveal the planet in unprecedented new detail. This is the Earth as a dynamic, living organism. How nature's unseen forces interconnect in extraordinary ways. And ultimately, how they sustain life itself. This is how the world works, as seen from space. "500 kilometers west of Africa, in the coastal waters of the Cape Verde Islands, fishermen are busy. Every few days, storms stir up nutrients from the deep, attracting great shoals of fish. The men and their families depend on these bountiful seas. A band of thunderclouds approaches. The fishermen must hurry to land their catch. It's the warmest time of year, and something extraordinary is occurring. An event which reveals just one part of a vast and ancient cycle that affects the whole world. It can only be seen using the latest technology from space. "700 kilometers above, a supremely sensitive satellite called Aqua records a change in the water temperature. Aqua's infrared scanner detects that the ocean has reached 79 degrees Fahrenheit, a critical temperature. Seen here in yellow, warm seawater starts to evaporate fast. Vast areas of vapor suck the sun's heat from the ocean and transfer it to the air. Water's ability to transport energy will soon wreak havoc on the unsuspecting inhabitants of the southern United States. Aqua is just one of over 100 satellites that are revolutionizing our understanding of the Earth. The satellites measure, record, and transmit terabytes of data every second. Now, this data can be used to build a unique digital portrait of the entire Earth in action for the first time. The Earth as one gigantic supersystem. Aqua's particular ability to track invisible water vapor reveals the sheer scale of just one part of this system: the interaction between the sun, the ocean, and the air. Although the fishermen can't see it, 180 tons of water rises upward every hour. It takes with it energy equivalent to the output of a small nuclear power station. One kilometer up, this vapor condenses into cloud and releases its heat. It raises the temperature of the surrounding air by several degrees. As the air heats up, it rises further, producing powerful vertical winds. These drive the clouds up to 15 kilometers high. As the storm cell grows, the effect of the Earth's rotation below forces it to spin. The thunderclouds merge into a vast circle. A hurricane is born. Viewed from high above, a hurricane is one of nature's great powerhouses. At any one moment, it's generating as much energy as the world's entire electrical output. Seen from the International Space Station, the hurricane crosses the Atlantic Ocean and enters the Gulf of Mexico, where warmer water feeds this gargantuan storm. Humans are about to bear the brunt of the power of the sun on the ocean. The hurricane unleashes its pent-up fury. "200-kilometer-an-hour winds twist steel like paper. Homes are ripped apart. This is the physical consequence of water's ability to store and release energy. In just 12 hours, the hurricane reshapes 600 square miles of Louisiana. Several 100,000 people are displaced. The inhabitants might curse their misfortune, but the remarkable truth is that we all owe our lives to the process that produced the storm. A hurricane acts like a release valve when the ocean gets too warm. It helps balance the climate by redistributing the heat around the planet. This particular one cooled large swathes of the Atlantic by over 4 degrees Celsius, returning the ocean to equilibrium. But even a Category 5 hurricane is just a tiny brushstroke in a much bigger picture. Our new technology, our eyes in space, are revealing how everything is interconnected on a planetary scale. It's these hidden connections that ultimately keep us alive. As the Earth spins on its axis, dozens of satellites look down and record temperatures, pressures, electric charges, and even the slow movements of the landmasses. This new way of looking at the planet reveals many fundamental facts, including why some parts of the world are fertile and others are not. It's June. Humankind goes about its daily business. In the Big Apple, New Yorkers commute in 25-degree heat. A breeze blows from the east, and the city basks in the sunshine. "11,000 kilometers away, in Delhi, taxi drivers struggle to cope with torrential rain. The deluge falls so fast that the streets are flooded in minutes. Meanwhile, seen from orbit, a wildfire rages in northern Australia. And beneath these clouds, hailstones pummel Shanghai. Before the Earth was visible from space, it seemed that such events were unrelated. But in fact, everything is linked. Joining together the data from 5 satellites reveals one part of the system, one layer. The ever-changing atmosphere that encapsulates our world. This remarkable animation shows how the atmosphere carries moisture on a global scale. Seen here in extreme fast forward, 2 seconds is equal to a day. The vapor is normally invisible, but now it can be viewed. The whole world in a single frame. When the data is wrapped around a model of the Earth, it gives a new perspective on our planet. All the world's weather is actually driven by one process. The region around the equator receives the highest share of the sun's energy and produces most of the water vapor. A huge band circles the globe. The vapor systems always travel in the same general direction, outwards towards the poles, driven by prevailing winds and the spin of the Earth. In the northern hemisphere, they circle clockwise. Vast swirls of vapor, spanning 3,000 kilometers. southern hemisphere, they spin counterclockwise. The Earth, always seeking an equilibrium that it never can reach. As these vapor-laden winds strike the various land masses of the Earth, they produce conditions specific to each place. One example occurs in western India at the end of July. Warm, moist air is forced up by a mountain range called the Ghats. Huge clouds bubble up. We call the result the monsoon. Billions of tons of water fall out of the sky, transforming parched land into fertile plains. In China, the monsoon fills up countless paddy fields. This process nourishes 3.5 billion people. Half the world's population. In contrast, on the other side of the world, the prevailing wind must cross the high mountains of the Andes before reaching central Chile. The altitude strips the moisture from the air, creating one of the driest places on the Earth, the high desert of the Atacama. There are places here where no rainfall has ever been recorded. Vapor is one of the fundamental forces that sustain life. But it's just one component of an even more complex, interlinked mechanism. To see the next piece means turning the world around and looking at it from another remarkable perspective. From below, where a whirlwind the size of a continent rages. Seen from space, the Earth is a place of extremes. The hot equator and the frigid poles vary by 70 degrees Celsius. This plus and minus of temperature pushes air and water around the globe, driving invisible mechanisms that support life in the most unexpected ways. One of the best examples occurs in the cold, dark waters of the Southern Ocean at 60 degrees south. These are the screaming 60s, the roughest seas on the Earth. Here, storms and persistent winds whip the ocean into a ceaseless frenzy, moving 130 million tons of water every second. All this is powered by the movement of heat from the equator to the poles. But these harsh seas also hold a surprising secret that affects almost the entire world. To understand why means traveling still further south, to the underside of the planet. Antarctica is 1.5 times the size of the USA. It's in continuous darkness for almost 6 months of each year. In winter, temperatures can drop below -80 degrees Celsius. This hostile place remains the Earth's last great wilderness. But there are a few people here, scientists who are unraveling Antarctica's secrets. Adding to the data gathered by the satellites above, the scientists are searching for the global significance of this frozen place. They have found that a unique set of circumstances make Antarctica especially cold. In turn, this super low temperature plays a vital role in supporting all kinds of life, even in lush jungles thousands of miles away. These images are made by piecing together the data from 17 different satellites as they look down on Antarctica. They reveal a massive weather system endlessly circling the entire continent. The huge whirlwind is driven by the rotation of the Earth. As warm, moist air migrates south, it is spun around and around, forming a gigantic invisible system called the polar jet. The relentless wind drives the seawater below. The Southern Ocean is the only circle of latitude in the world with no land. As a result, a huge circular current spins incessantly, 11,000 kilometers in diameter. The strongest, most persistent ocean current on the planet. It's the combination of vapor, water, wind, and the shape of the Earth that makes the 60s scream. The polar jet is so powerful, it isolates Antarctica from the rest of the world, preventing much warmth or moisture from reaching the interior, creating the world's driest, windiest place. Here, blizzards are caused by wind lifting snow from the ground, rather than precipitation from the sky. The dense, frigid air, a direct result of the polar jet, keeps the entire continent extremely cold. And in winter, the harsh conditions trigger a life-sustaining process that takes place beneath the ice. Here, hidden from view, something extraordinary happens that affects the whole world. Each winter, 25,000 gigatons of sea ice form around Antarctica, and it grows by more than the size of Australia. This animation, using 2 years of satellite data, shows how the continent is constantly changing. The greatest seasonal shift anywhere on the Earth has a profound effect on life across the planet, and it's all because of the physics of salt water. To see this process in action means observing Antarctica as winter descends. Night falls, the longest night on Earth. A katabatic wind blows. It is driven by cold air falling from Antarctica's mountains. The 150-kilometer-per-hour blast brings everything to a standstill. Emperor penguins are one of the few animals to remain here throughout the winter. But even they are barely able to survive these bone-chilling conditions. In a remote area of coastline called the Weddell Sea, a series of polynyas form. These are large regions of open saltwater surrounded by ice. Here, the katabatic wind cools the seawater to sub-zero temperatures. A critical threshold is crossed once the upper layer of ocean falls below -1.5 degrees Celsius. Now another remarkable property of salt water takes over. On the surface, the sea begins to freeze. At a microscopic level, tiny crystals start to grow, knitting themselves together. As it freezes, the seawater must release its salt. The water that isn't frozen becomes saltier still. It forms a brine that drips down narrow, elongated tubes in the freshly made ice. The brine is denser than regular seawater, and it sinks downwards. This heavy salt water takes with it oxygen from the air above. Now it carries that oxygen into the depths below. The formation of ice accelerates in speed and scale. Soon, large slicks appear on the surface and begin to thicken into a solid mass. What started as a microscopic process can be seen from space within just 7 days. Now, the latest surveys by satellites and submarine sensors reveal an ancient yet invisible consequence of this remarkable transformation. Every second, 1.5 million cubic meters of dense, salty water sink downwards. An unstoppable vertical current. Where the water meets the sea floor, it spreads out over hundreds of kilometers. It cascades over the continental shelf. A vast submarine waterfall appears, never seen by human eyes. A torrent equivalent to 500 million Niagara Falls. The cold, dense, oxygenated brine falls slowly, silently into the abyss. It will not resurface for at least 1,000 years. This animation, using data from a group of satellites called GOCHI, reveals what happens next. When combined with other measurements, it shows how the outflow from Antarctica drives water back towards the equator. A steady flow of deep, cold, salty liquid migrates northwards. As these slow-moving currents travel silently across the globe, they stir and cool all the world's oceans. This ancient system regulates the average temperature of the water to within half a degree. Such stability has enabled life to prosper, protecting it from wild swings in the planet's climate. When finally the deep water returns to the surface, it begins a more dynamic existence as it joins warmer, faster currents. Seen from up here, the entire ocean is revealed as a single, never-ending swirling mass. These surface currents vary in temperature depending on the energy they receive from the sun. This in turn determines the amount of vapor that is released into the air. It's these variations that drive seasonal changes on land as well as ocean. As the Gulf Stream cools in the fall, it causes New England maple trees to turn red and shed their leaves. 6 months later and half the world away, another current called the Kuroshio starts to warm, and cherry trees burst into blossom all over Japan. Similar processes are happening all across the world, governing the seasonal cycles of almost all life on the Earth. Seen from space, the ocean and the atmosphere are intrinsically linked. A continuous system joined together by water, 12 trillion tons of which is floating around in the air at any one time. Every single storm, every single raindrop is one part of this vast engine that powers so much of the activity that defines our world. But there's still more to this planetary mechanism than there seems. The cold Antarctic brine will soon undergo another transformation as it interacts with one of the Earth's most violent systems. And where fire and water meet, something magical happens. A process that underpins almost all life on the Earth. To the west of Peru, a massive feeding frenzy erupts. Millions of anchovies and sardines feast on plankton. Millions more predatory fish and seabirds migrate here to feed on the shoals. It is one of the densest volumes of marine life known, which is why humans are here too. But this is more than a rich hunting ground. It is also one of the best examples of how two of the Earth's systems interact to support life. The first of these is the water cycle, but the other is contained inside our globe, the hot, molten interior. It's here where almost all the other materials needed to build life originate. The world is not a solid ball of rock, but more like a molten sphere of superhot liquid with a cool crust on the outside. The Earth's surface is like the skin of a raindrop, and it's inherently unstable. A magnitude 9 earthquake hit Sendai with such incredible force that it pulls parts of Japan 2.5 meters towards the USA. At the same time, half the world away, a volcano erupts. It fires a vast pyroclastic plume of ash high into the stratosphere. Such violent events are just local disturbances caused by the ancient, slow currents of molten rock that constantly circulate inside the Earth, fueled by the radioactive decay of the Earth's core. It is this material leaking out through the crust that provides the basic elements needed by life. Two systems, one fiery, one watery, interact in many places. The most important occurs on the ocean floor. 2,500 meters beneath the surface, at the bottom of the Atlantic, lies a chain of submarine volcanoes. All around, lava and superheated gases spill out. The end of a 25-million-year journey, all the way from the Earth's core, far below. This acidic and toxic world, where pressures are hundreds of times higher than on the surface, is where the basic chemistry of life is done. Gases that would normally bubble away react vigorously with the dense, oxygen-rich seawater from Antarctica. The hot minerals that have cycled through the planet's interior so long dissolve into this seawater. Now they react with the oxygen and become powerful materials called nutrients. The seawater, now packed with minerals from inside the Earth, emerges through hydrothermal vents. Living creatures scramble to make use of it. Bacteria are the first to colonize the vents. These tiny organisms thrive in such fertile conditions. Soon, more complex creatures feed on the microorganisms, and they in turn are fed on themselves. The nutrients are so plentiful, they cannot all be used here. Ocean currents will carry the surplus away and transport them all around the world, and ultimately to the surface. Other currents erode the Earth's land masses, stripping minerals directly from the rock. Back in the rich fishing grounds off Peru, deep ocean currents are driven upwards as they near the South American landmass, bringing a richness of nutrients with them. Phytoplankton. Microscopic plant organisms make dramatic use of the nutrient-rich water and sunlight. Carbon dioxide is dissolved from the air, giving these tiny single-celled creatures all they need to thrive and reproduce. Now they multiply in their billions. What started as a small patch of plankton proliferates exponentially and can soon be seen from high above. Within just 24 hours, 500 square kilometers of ocean turns from blue to green. The plankton bloom triggers one of the largest feeding frenzies on the Earth. Similar upwellings of nutrients around the world trigger more plankton blooms. Plankton blooms, seen here as vast ribbons of green, can cover as much as 1/5 of the planet's oceans. Plankton is the base of the food chain that conveys the Earth's minerals directly to the billions of tons of living things in the oceans. Minerals that have spent millions of years circulating inside the Earth now form the building blocks of marine life. Within a further 24 hours, the plankton that have not been eaten sink back down into the abyss. They take the carbon and minerals they have ingested with them, all the way to the ocean floor. Here they will stay for many millennia, a thick covering of tiny carcasses up to 1 kilometer deep. Eventually, many will re-emerge in the next step of the system and provide the vital chemicals needed to continue the chain of life on land in a most unexpected way. This process plays a pivotal role in shaping the food that we eat and the air that we breathe. It even sustains the richest surface habitat on the planet, the Amazon rainforest. To see how that works means visiting one of the driest and dustiest places on the Earth. The violent Sahara. The Earth's systems operate at many different tempos. Some, like the weather, are quick. Others take many millennia to complete a single cycle. Modern satellite technology has only just revealed how the slow and the fast link together, and the results are extraordinary. This parched land, the Sahara Desert in Africa, was once lush and green. But even today, it plays a key part in the cycle of life on the Earth. It's May, the height of the dry season. Camel herders travel through one of the most exposed regions of the Sahara, an ancient inland sea that dried up 5,000 years ago. The Bodele Depression. The ground beneath their feet, called diatomite, is made from the ancient corpses of plankton. It's rich in compounds of iron and phosphorus, two elements needed by all known living organisms. More remarkable still, these very grains of sand will in just 6 days' time breathe life into a tropical rainforest 5,000 miles away. It takes just one flake of diatomite to lift into the air to start the process of rebirth. The flake fractures into a fine powder that's carried off by the wind. Soon, more microscopic flakes fill the air. This visualization, made with data from a satellite called Meteosat, reveals a daily pulse of dust. Here it's shown as a cloud lifting from the desert. The dust rises with an almost clockwork precision at noon each day. What started as a microscopic process is now a vast dust storm. It's 100 stories high and several hundred kilometers wide. The cloud of ancient plankton is now blown across Africa. At the west coast, the dust is drawn upwards high into the sky and begins an epic voyage across the Atlantic, carried by the prevailing wind. Satellites reveal that 54,000 tons of dust is transported 8,000 kilometers to the Amazon in a single day. It's here in these clouds, high above the rainforest, that the ancient plankton is reborn in spectacular fashion. The minerals in the dust dissolve into water droplets. It falls onto the Amazon with the rain. Precipitation falls incessantly throughout what is now the Amazonian rain season, delivering a total of 40 million tons of African dust into the forest below. What was once plankton now passes into the soil and into the tree's roots, revitalizing the forest. The fertilization of the Amazon by Saharan dust remained invisible to humans until the advent of a satellite called Terra. Terra's instruments are so sensitive, they can not only observe the dust migrate to the Amazon, they can measure the growth of the canopy from space. It's possible to watch what happens at the end of the rain season when the sun returns. For the first time in 6 months, the sun shines directly onto the forest. The result is an explosion in growth. For every leaf there is now, 3 more will appear in just 10 days. A wave of green crosses the continent. The migration of Bodele dust to the Amazon is just one of thousands of similar processes that distribute vital minerals to living habitats all over the world. Deserts, mountains, and ancient sediments. Each one has a different composition, and they enter the chain of life in a myriad of ways. Each unique soil around the planet depends on these processes. The Great Plains of North America are formed from glacial deposits, perfect for the production of wheat and corn. In Bangladesh, the Ganges Delta is rich in iron eroded from the Himalayas, an essential ingredient for growing rice. Other minerals are transported in air, water, and ice all around the globe. And this, in turn, has enabled plants to radically reshape our planet. Plants are more than just a product of the earth. They, in turn, are a powerful force that over hundreds of millions of years have modified the planet. They have changed the composition of the atmosphere and have defined what we humans are, shaping many aspects of our bodies and even our minds. Another remarkable view of the Earth, as seen from space. This computer visualization shows the daily pulse of invisible gases oxygen and carbon dioxide in the air. But these vitally important materials are not produced by some geological process. They are made by trillions of tiny breaths far below. To see how it works means returning to the Amazon. This rainforest is about 55 million years old, one of the oldest living systems on the Earth. It is so biodiverse that half of all life calls this place home. A massive 5.5 million square kilometers of vivid green. Like the Antarctic or the Sahara Desert, this ancient ecosystem plays a vital role in the rhythms of the entire Earth. In this case, the process starts in tiny holes on the undersides of billions of leaves. During the day, the leaf takes up carbon dioxide from the air. It converts the carbon into sugar and releases the volatile gas we call oxygen. Over the course of its life, a tree will release millions of cubic meters of this precious gas. Every day, the Amazon processes a fifth of the world's oxygen. For decades, it has been thought of as the lungs of the Earth. But now, satellites are helping to show that it's not quite as simple as that. The Terra satellite has recently observed that most of the oxygen the Amazon produces is reabsorbed into the forest at night. To release an excess of oxygen requires one more step. Two million tons of sediment washes from the rainforest into the vast Amazon River every 24 hours. The sediment drifts eastward 6,000 kilometers and into the Amazon Delta. Here, plankton in the water absorb the sediment, and with yet more sunlight and carbon dioxide from the air, the plankton population explodes once more. The bloom releases a pulse of oxygen so enormous, it can be seen from space. Half of all the oxygen in the atmosphere comes from plankton blooms. These tiny creatures are the real lungs of the Earth. It is they who maintain the precious balance of the air. This in turn allows the next link in the chain of life. An atmosphere rich in volatile oxygen allows more complex dynamic creatures to exist. Creatures who can move quickly using tails, wings, arms, and legs. In fact, the balance of gases in the air defines the size of our bodies and ultimately governs almost everything we are. But oxygen appears to have a downside. It is so volatile that it can trigger violent runaway reactions. The most deadly of which is fire. Even this inferno is just another piece of the intricate jigsaw puzzle that is the Earth. It's October. A massive wildfire burns in the Yukon. These flames will devastate 25,000 square kilometers of forest in less than a week. At the same time in Siberia, 4,000 hectares of forest are aflame. But even this is only a small part of the influence of fire across the globe. Seen here as thousands of red dots, over 1 million square kilometers of the Earth is ravaged by wildfires every day. Fire is another of the Earth's remarkable systems. It plays a crucial role in the cycle of living things. A good place to see it in action is the boreal forest in northern Canada. This vast spruce forest has a special relationship with fire. Here, dead and diseased trees lay practically dormant. Such is the cold. Locked in this timber are the ingredients needed to make new life. But left like this, these trees would take many hundreds of years to break down. Fire can shorten this process to a matter of hours. Most natural wildfires start in the same way, with a random electric bolt from the sky. The spruce tree is the perfect fuel. It combusts with such ease and immediacy that one spark and it bursts into flames. This is how volatile oxygen delivers its deadly blow. Oxygen in the hot air makes new bonds with the carbon atoms in the wood of the tree. This generates heat, which makes the oxygen bond faster still, creating yet more heat. The flame intensifies. As the inferno rages, the energy from the sun that's been stored inside the plant as it grew is released. And that's what fire is. Watch a fire burning, and you're witnessing the power of the sun released from the life that has stored it for so long. Within a matter of hours, what started as a spark turns many hundreds of hectares of forest to flames. The organic matter these trees have stored for many hundreds of years is quickly turned to ash. These flames also remove the dead and deceased organisms which inhabit the forest and recycle them, returning their minerals back to the soil. Look at fire this way, and it becomes a beautiful process of regeneration and rebirth. Fire has been around ever since plants evolved. They produce the oxygen, and at the same time, they grew the material needed to burn. But plants not only make fire possible, many depend on it too. The spruce tree, for example, has evolved to drop its seeds in the ashen aftermath of a blaze. From space, we can see the effect fires have across the world. A pulse of new growth follows every blaze. Wildfires maintain the health of many of the world's habitats. Ecosystems that would otherwise stagnate instead regenerate. The satellites reveal how fire, weather, water, and ice combine to sustain the cycle of life. Everything is interconnected in an ancient and intricate system. But even this is just the beginning of what satellites are discovering. They can analyze and explore how the Earth reacts to external influences. And there's no greater influence than that of our local star, the Sun. As the Earth rotates over 24 hours, the planet responds to the extraordinary power of the Sun. Each day, 170 million gigawatts, over 7,000 times the power that humanity consumes, rains down on the surface, triggering a wave of activity that never ceases. At dawn, plants and plankton begin to photosynthesize, using the light to make sugars and starches, the basis of the food chain. The power source for almost all living things. Sunlight drives wind and weather around the globe. When the air cools at night, it triggers much of the Earth's rainfall. We are part of this circadian pattern too, built to respond to the daily influx of energy from above. The cells in our bodies need sunlight to create vitamins in our skin. Even the flight paths of planes reveal our intimate relationship with the sun. Aircraft travel westwards in the morning to extend the day. and eastwards in the evening to reduce the night. But ironically, the biggest threat to this finely balanced arrangement is from the same thing that allows it to exist in the first place. The energy given off by the sun. The SDO satellite records the ultraviolet radiation released by our star. Charged particles, fractions of atoms, protons, electrons, and neutrons are constantly thrown out, along with massive pulses of electromagnetic radiation. But occasionally, the sun throws out what's known as a coronal mass ejection. This supercomputer visualization shows a cloud of plasma millions of kilometers wide, racing towards the Earth. If these solar particles were free to hit the Earth's surface, they would do serious damage to any living thing, producing fatal mutations in their DNA. Fortunately, the Earth has a defense. An invisible force field called the magnetosphere surrounds our planet, visualized here in unprecedented detail. These images are generated by data from 5 magnetically tuned satellites. Called Themis, the network of spacecraft reveals the force field as it is constantly bombarded by the sun. The shape of the field is produced by the sheer force of the radiation hitting it. A nebulous teardrop 200,000 miles in diameter. As wave upon wave of solar particles strike the magnetosphere, most are deflected. But when a coronal mass ejection arrives, the charged particles peel open the magnetic field's outer layer. The particles are now free to rush in towards the planet. The Earth's inner magnetic field steers the radiation towards the poles, triggering one of nature's most remarkable sights. The northern and the southern lights. Here, we can see the Earth's second layer of defense. Giant ribbons of plasma stream downwards, encircling both the north and south poles. As they strike the upper atmosphere at extreme speed, they excite the molecules of air. The process makes the air molecules glow. The oxygen radiates red and green, the nitrogen blue. Energy that would otherwise mutate all life on Earth is dissipated by the upper atmosphere. In this way, the Earth has shielded itself from the sun's deadly radiation for millions of years. But even this extraordinary apparatus is only one part of how the atmosphere protects life. Down below, there are yet more powerful systems, without which there may be no life at all. The Earth's atmosphere is a delicate resource. A thin blue shell that encapsulates our world. The bombardment of sunlight and heat subjects this slim coating of oxygen and nitrogen gas to incredible stresses and strains. Forces so powerful that if left unchecked, would tear the atmosphere apart. Nighttime from space. The Earth buzzes with lightning. Astronauts in the International Space Station are often amazed at the intensity and frequency of the electrical storms that take place far beneath them. Why does the Earth need these relentless storms? The answer is clear when seen from high above. The Earth's atmosphere is seeking equilibrium. Each day, the combined force of sunlight and vapor creates 40,000 thunderclouds. The clouds build up vast stores of electrical charge. Every half hour, 100 megawatts is generated inside an average thundercloud. Enough energy to power the city of Toronto for a minute. To equalize itself, it must transmit the negative energy down to the ground as lightning. But at the same time, it transmits a positive charge upwards into the sky. A vast column of charge rises out of every thundercloud. This invisible force moves at almost the speed of light towards the atmosphere's outer shell. This is the ionosphere, a thin veil of mostly hydrogen and helium gas. Now, for the first time, it's possible to see electric charge interact with this rarefied realm. The ionosphere acts as an electrical conductor. It distributes the charge all around the globe. And we now know that without this global electrical circuit, there may well be no life at all. It's all due to an incredible chemical reaction, which takes place inside thunderclouds as lightning strikes. The The electric charge inside the thundercloud grows until it's so strong that the air breaks down into ions. A tiny path forms in which an electrical current can flow. Within 1,000th of a second, a lightning bolt is initiated. It's no thicker than a human thumb, yet 5 times the temperature of the surface of the sun. As it burns through the air, this bolt of energy breaks the nitrogen molecules in the air apart. Oxygen bonds with the nitrogen, creating a substance called nitrate. Approximately 14,000 tons of nitrate is transported around the world in weather every day. It falls to the ground in rain. Nitrate is vital to almost all forms of life. From the photosynthesis of plants to the respiration of more complex organisms, nitrate has driven key chemical reactions in living things for millions of years. Looking at the Earth as satellites do reveals an intricate mechanism that shapes every moment of every day and drives every beat of every heart on the planet. But there is still one part of this system that's missing. And that is the profound and undeniable effect of a single species of animal, the human race. Looking at the Earth from space has revealed a system of hidden complexity, interwoven at every level. Slow-moving processes connect with others that happen in microseconds. Endless cycles abound. Cycles of death, decay, regeneration, and rebirth. From the relentless power of water and sunlight to the electromagnetic forces at work all around us, every interaction reveals a finely tuned balance. Humankind is the latest natural phenomenon, a direct consequence of a system that has created and sustained life for 3.5 billion years. We have evolved intelligence. This single fact has enabled us to add to the Earth's ancient processes. We've transformed the planet by exploiting the complex system that produced us. Our ability to control our habitat has resulted in rapid population growth and our dominance as a species. Today, our effects can be seen across 80% of the Earth's landmass. We have even extended our scope into space. And now we are finally beginning to understand how the world works and our place in it. This is a pivotal time in the Earth's history. Look at the planet as satellites do, and we see that we have become a global force ourselves. We already manufacture more nitrate than lightning. We produce more airborne sulfur than all the world's volcanoes. We release more CO2 than the Amazon captures. Our cities generate dust, trigger electrical storms, and affect rainfall. We impact many of the Earth's cycles. Seen from space, humankind's influence can be considered a natural process. The gases released by ships and aircraft, cars and power stations are caused by an animal the Earth itself produced. But there is one key difference. Unlike volcanism, the movements of the ocean's currents, or the oxygen released from forests and plankton blooms, we have a choice of what we do. Satellites not only allow us to understand our impact on the world, they enable us to make informed decisions about our continued consumption of its resources. Our eyes in space are showing us how to maintain the balance that sustains the natural world.